So hi, I'm Flokli. I'm an NixOS and Nix contributor. I maintain systemd, NSS, and some other low-level stuff there. But one of my hobby projects is tvix-store, which is a new implementation of a content at rest file system syncing thing. Also played around with casync a while. This thing is part of the Twix project, which is a work-in-progress re-implementation in Rust. And it's like the storage layer of that thing. But while talking to people about this, I realized like, oh, this thing actually is something bigger. And it's kind of like Git trees and the Merkle DAG that you know from there. Except it has a much nicer format. Like it uses Protos for the encoding. It's easier to parse. You know you kind of know the length of the stuff you parse, and it has a hash function with very nice properties. So I thought I want to show it to you. And some of the properties there. Once you know the root of the thing you want to fetch, everything else is content at rest. There's no timestamps in there, no user IDs, group IDs, no extended attributes. There's only one way to come up with the same tree when you have the specific set of contents in the file system subdirectory. And because it's all a Merkle DAG, you automatically get deduplication of identical subtrees in different parts of whatever you transferred with that, either in the same image or in like a previous version of the image. And you also get automatic deduplication for blobs inside that structure. And you can also do more chunking underneath if you want to like store this in a more efficient version, and then you can plug in casync, for example, for that stuff. Because we use Blake 3, we can do granular seeking into blobs, so we can start fetching data from a blob and have assurance about the integrity of the sub-chunks of the file you're fetching as you receive them, thanks to BOWs. So you don't really need to even trust the other side that you're substituting from at all, and you can detect very early if they send you like bad data. Means you can plug in peer-to-peer substitution, CDNs, whatever, doesn't matter where you fetch it from. Use cases, obviously, file system tree delivery. You might, depending on what you want to ship, you might want to have a separate layer for like users and stuff like this, but don't really need it for my use case. There's a container image delivery use case that you also might have. You could use it as a version control system backing store implementation, or for like more granular access into larger data set. Think about like training data, and sometimes you produce the same results, or you want to have it in different constellations, and you want to deduplicate all that. We have an in-memory backend. We have a local key-value backend written in Sled, using Sled. I want to play with other storage backends. We also have a Fuse file system to mount it. There's a gRPC API to transfer things over the network, bindings for Golang and Rust. And some object storage implementations are popping up with, like right now, GCS and nuts. But it's fairly simple. The GCS one was implemented in 2 hours, at least for the non-verified streaming bits. I want more storage backends, more store composition to be able to express caching, things like that, and maybe an in-kernel storage module if people want to use this as their main file system. Yeah, if someone finds this useful, join the IRC channel, check the issue tracker, try to use it, and that's it.